Okay. So we'll develop a mini game. We call this as guess the number. Okay. So let's see how do we do that. So to guess the number, okay, we need to, one second. Okay, to guess the number, let's have this number equal to, let's say, 56. Okay, and you will ask the user to guess the number, right? So how do I ask the user?
Input.
Sorry? Input,
Yeah,
exactly.
input.
Yes. Okay, so one second. Yeah, so we will say input. Okay, so I'll say guess equal to input, right? And let's say we'll say guess the number, right? And so obviously when guess and number matches, right? So we can display a message saying print congratulations, you have successfully guessed the number, right? Now, if it doesn't match, okay, we'll say print, sorry, you didn't get it right this time. This time, yeah, right? So obviously this should work, right? So if I go ahead and run it, Python is still getting ready. Okay. Okay, this is not shown. So let me move this to program. It's still getting initialized. Okay, so I won't be able to open a new file. I'll put it here and then run this because by default prog1 is selected. So let's run it. Okay, so guess the number 45. Sorry, you didn't get it right. Okay, and now if I run it again and I say 56, 56 is correct, right? What happened? What happened? Why it's not showing this? Hmm?
Probably because the input isn't registered as int. So
Yes, it is not right. It is still string. Okay, so you have to convert into integer. You're comparing string 56 with integer 56. Okay, let me. Now you will get it right. Okay, if I say 56. Okay, so now let's add one more layer of complexity. Okay, is that let's say that you keep on guessing till you get it right. Okay, so how do we do that? So 56 is one time, correct? And all these things should be repeated. You have to keep asking, okay, enter again, enter again, enter again, right? So what we'll do, we will use while because we don't know how many times we'll have to run this. So we'll go ahead and say while true, okay? And we'll move all these inside while true. So I've selected and I'm hitting tab button. So it'll all go inside this, okay? And sorry, you didn't get it right this time. I can say try again, okay? Now, when you run it, it is 45. You didn't get it right, try again, 89, okay, 56, and okay. Now what happened? It is still continuously asking, even though you got it right, because this is while true. We have to break it. So we have to break it when you get it right. Okay, so let me force stop here, and we can put a break command here, right? Okay. Now let's do one thing. Let's give hint to the user. In a sense, like when you get it wrong, right? We don't know. Okay. Guess the number and let's fix it between 1 to 10. Okay. 1 to 100 maybe. So now when you get it wrong, let's give hint to the user that whether your number is higher than the guess number, actual number, or lower than the number, right? So instead of one else, we need to have two more conditions. One, what if the guess is higher? And second, what if guess is lower? If it is equal, yeah, you are here. But other than that, there are two options, right? Once, let's say we guess 45, 23, 25, those are lower than the actual numbers. And then you have 95, 85, 75, which are higher than these numbers, okay? So what we'll do is, we will create elif here. And here we'll say if guess is less than num. And we'll say, we'll copy and paste and we'll make changes here. So we'll say, sorry, your guess is, shall I put higher or lower here? Your guess is higher or lower? What will this be? Your guess is lower, right?
Yes, it's lower.
Yeah, so your guess is lower, try again. And we'll copy same stuff and we'll put it here. And here we'll say your guess is higher. Okay, so now let's play this again. So I'm going to say 45 and says guess is lower. Okay, try again. Here I'll say your 78. Your guess is higher. Try again. 56. Let's, okay, successful. Okay, I think this is working fine. Now, let's try to count the number of steps you have taken to guess the number. Okay, so we will have counter here equal to 0. And every time you guess, right, counter should increase because this is when you're guessing, right? Every time you're guessing, you're using a chance, right? That is the number of times you are guessing, obviously, right? So I'm going to say here, counter equal to counter plus 1, right? This is same as counter equal to counter plus 1. And here we can say you have successfully guessed the number in so many steps, right? So many chances, steps. And I'm going to put F here, copy and paste. Okay, so we'll run it again. We'll say 25. Okay, oops, I entered twice. Okay, 25, lower 75, higher 56. Perfect. So it took us 3 steps, right? All good so far? Any questions?
Awesome.
Okay. Now let's make it truly a game. In the sense, here we know it is 56. Okay. But instead of 56, let's make computer think of a number randomly. Okay. So first I'm introducing you the concept of module now. Okay. So far we have been seeing functions like print, input, int, str, bool, etc. Okay. Those are in, you can say, global module, which is available to all the programs. But there are lots and lots and lots and lots of functions more. Okay. Now, all functions are generally not attached or available in the global module. Okay. What I mean by that is, okay, it's you want to call int, you just call int. You want to call input, you just called input. You want to call print, you just call print. So there are very few, okay? I mean, there are large numbers, but very few compared to all the options that we have. The one of the reason why Python is so popular is you have function to do almost anything in this world. Anything. You would have gone through your physics classes, right? You have those complex problems. If you have if you have done electronics like communication theory and things like that, the high level mathematics operation, even you can formula to bridge to find the strength of a bridge and all those things, like all we have functions for all of this. People are developing. You and I can develop a new function and upload it to PyPy. That's called Python index. Okay. Now the thing is, if everything were placed in global, it will be a mess, right? And for a program, it will be difficult, because when we load our Python program, it will take a lot of time to load all the things. It's like this. You're going on a vacation, right? If you are going on a vacation, why don't you carry entire home with you? Right? You can carry entire thing, entire set of dresses that you have, entire set of shoes, entire set of everything that you have. But it doesn't make sense. If you're going for a 5 days vacation or 2 days vacation, it doesn't make sense to carry maybe, let's say, more than 4 pairs of dresses, right? It doesn't make sense, because it's going to make your bag heavy. Same thing, okay? If you are using 5-10 functions, it doesn't make us to add everything to global. So what Python has come up with is concept of modules and packages. Modules are files, .python files, just like we have created this. So difference between our program and that module is that module has set of functions. Now those functions are not automatically available for us to use. You have to say, I need to carry that. I need to carry so and so module. I need to carry so and so module. So when you carry so and so module, that's when those functions will be available for use. So those are like, it's like in your house you'll have different cupboards and your things like for to put things, right? Maybe at one place you'll put all your stationery stuff, at another place you'll put all your electronic stuffs, right? You don't mix everything and put it in a single room, right? Because it becomes easy to call, is easy to know where your things are. So same way, you assume that modules is a way of arranging things properly. And based on what you need, you go and check. I need functions to help me generate random numbers. So we have a module called as random. Now when you use random, or for the matter, when you use any module, there's a different way of using it. And that's what I'm going to show you right now. So there's a module called as random. And later when we are done with functions, we'll create our own modules and packages. So modules are single Python files which will have lot of functions. Lot of functions which are related. And module name is nothing but the file name. So if I create this file as module, this module will be called as prog1. So file name is the module name. And when I say import random, I mean to say that give me all the functions only, not independent code. So that's why this is not a module. We need to write functions here. Then it becomes a module. So I'm saying give me all the functions that are available in random module. Packages means collection of modules. So when you have multiple modules, you put them together in one folder. So the folder name becomes package, and package with one package name, with one folder name, you're able to access all the modules that are there in that folder. So module is a file, package is a folder. Module one file will have multiple functions and classes. It can have classes and functions. Packages will have multiple modules. So we will also learn a few packages as we go along, and we will also see how to use those packages how to create those packages when we are doing functions, okay? Functions and class and objects, and then we will see how to create our own modules, how to create our own packages, okay? So now I'm working with random, and you want to see all the functions in random, you have to say random dot, okay? The moment you see random dot, okay, see these are classes. C is for class, V is for variable. So see, there's a random class, there's a system random class, there's a random variable, okay? Now these are your variables, and I'll be using, so this is, these are variables which are available for us to use, okay? We'll get a value, okay? And these are classes, okay? So these classes, you can use it. For now, I'm going to use randint. I'll show you some of these things, maybe, okay? Choices. Okay, so let me tell you, the things which are mostly used, and we will do this. I have plans to use random date time when we are done with modules, okay? When we learn modules, we'll get deeper into this. For now, we'll use what is required for us. So here, when you say random choice, okay, you have to give more than one choice, and it will return you randomly. It will select one choice. So if I give choice as choice 1, 2, 3, 4, 5, 6, it will give me randomly one from 1 to 6. Random number, random will give you random number which is between 0 and 1. So you'll get 0.23, 2, 3, 4, 5, something, okay? Every time you run, you get a different number. Rand int will give you random integer value. So you don't get decimal values, you get integer values. And you can tell which all integer value you want. So when we use this, we need to give a range here. So we say, okay, so let me use random int for now. You have to say rand int, okay? And then I need to say which value I want to use. So in this case, I will say 1, 100. So when I say 1, 100, I'm going to say that give me a random number between 1 and 100. Okay, give me a random number between 1 and 100. Okay, both inclusive. This is different than range that we have done. In range and all the other functions that we'll do later, okay, in NumPy, Pandas, etc., you'll see that ending number is up to, not including. Okay, ending number is up to. But random int, remember, it's little different. Here, both the numbers, starting number and ending number, both are inclusive. So if I say 1, 100, it will generate any random number between 1 and 100. Every time you run it, it's going to create a new number. So I'll take this, okay, and I will put it here. Now to show you first time, let me print this number. So I'm going to say number equal to num, and I will print a line here, okay, so that we know what we are talking about, okay? Any questions so far? Did you understand why I'm using random number? I want computer to generate a random number, okay? Then it truly becomes a game, right? Otherwise, we know it is 56 and we can win in any number of steps that we want to. So see, it has not thought of 16. I'll stop this program and run it again. Okay, see now it's thinking of 53. Every time you run it, it will think of a new number. Okay. Okay. I wanted to add a couple of more features. Then we'll come back and we'll do random number. Okay. Because it becomes difficult to test. Okay. Let me do a couple of more features. Okay. So let me put 53 for now. We'll come back and we'll do this later. So what I wanted to do one more feature is, let's say I'm telling the user to guess the number between 1 to 100. But what if I enter -1? Okay. So when I enter -1, since it is outside this range, we'll have to give a different message. And let's say we don't count that step. So what we'll do here, it's here. I'm going to say if guess is less than 1 or guess is greater than 100, right? Then you say print invalid number. Try again. Okay, try again. And let's say you don't want counter to become 1. So what I'll do, I'll say continue. Okay, I'll say continue, so that what happens? Your program goes back to the beginning,
Start.
right? So the counter is not increased, correct? Okay, the moment you come here, it goes back to the while. Now, if you run this and see, okay, enter the number. I'll say 34. So it should be counted as 1. 90 counter should be 2. Now I'll say 109. Okay, it says invalid number. Okay, so you have 2 legal attempts. You can create your own logic. Here you can say invalid means, your game should end, that you lose. Or you can have say that, one invalid step means your counter should become increased by 2, right? You want to
Yes.
penalize, or you want to ignore. Okay, so I'm trying to ignore. So you can have your own logic. I just wanted to show you how to use continue here, right? So 2 steps, right? Now I'll say -8. Again, same thing. Now I'm going to give 53. So say it says 3 steps. Okay, it ignored your 109 and -8 steps. So it took 34, 90, and the last step, right? So this is how you can use continue. Okay, now let's go back to the random number. Okay, so I'm going to delete this stuff and I'm going to uncomment this. So let's see this. So number is 31. Okay, so guess the number. Let's say I'll purposely guess 45. Okay, your guess is higher, right? So now we have to guess lower number. So we'll say 67. Okay, I said lower, but still I'm guessing higher. Okay, let's say 23. And finally, I'll say 31. So took 4 steps. Now, let me remove these 2 lines. Now we don't know exact number which computer has thought of. This is now the real game, isn't it? Now let's run it. Guess the number. Guess it, guys. Give me a number.
25.
25. Your guess is lower. Try again.
50.
50. Your guess is lower. Try again.
75.
25. Your guess is lower.
45.
Your guess is lower.
90,
Your guess is higher.
80,
Your guess is lower.
85.
Your guess is higher.
83,
Your guess is higher.
82, 81.
Okay. It took us 8 steps. Okay. So this is how you can play this game. Now I want to bring one more twist to this. The twist is, okay, so this is guess the number, computer versus human. That means computer is thinking of this number and we are guessing, isn't it? Now let's make it computer versus computer, right? So computer will guess the number and computer will come up with a number and also guess the number, right? So let me move this just as a backup copy. So when I upload, I'll have this copy as well. Okay, and we'll come here. Now we'll say computer versus computer. Simple, right? So instead of we guessing, okay, we'll let computer guess, right? So we'll say random dot randint. Okay, 1 comma 100. Now let's run this. Okay, so it took how many steps?
139 steps.
139 steps. Do you think we are better than a computer?
Yes.
55 steps. 49 steps. Okay, 264 steps.
Oh,
56 steps. Do you think we are better than computer?
yes, we took less
Only 8 steps.
Yes.
No, see, we had a logic. Logic was when you know that number is lower, you will not guess beyond that. Correct? But
Yes.
here what we're doing, every time we are doing random number. Okay. If I have to display, okay, so let's say we display the actual number and we'll display the guess number also. Guess number equal to guess number. And okay. 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 So what did I say here? That every time your program is guessing randomly. Okay. So when you run this, okay, so see here, actual number is what? To scroll all the way up. 74, right? It says guess is lower. So it has guessed higher number 79, which is good. Now it says guess is higher. So it guesses a lower number, which is good. Now you see 48. Oh, it's going so good so far. Now you see this. If you were there in the place of computer, you would have never guessed 95, correct? Because 79 itself is higher. Yes or no?
Yes.
79 itself is higher. So you would have never guessed 95. Right? Because it is randomly guessing the number. Okay, it's not using its brain. It's not using, oh, higher means I should not go beyond that. Right? See, for the first time, yes, it was random number. First time you have to guess a random number. But second time onwards, okay, you have to base your thinking or decision based on the previous output. So we need to change this. We have to change it based on how we were thinking, right? So what I'll do, I'll have a two variable called start and end, okay, equal to 1 and 100, which is good, right? So I'll say start and end. Okay, now you see, if this guess is correct, it's all fine. But in these two cases, we have to manipulate the range in which they are guessing, right? So now if the number is 50, let's say, if the number is 50 and you have said 25, next time onwards, you should not guess a number less than 25. Yes or no? If number is 50 and you say 25, so computer will say your number is lower. Think of a higher number. So next time you should not think of a number lower than 25. Correct?
Yes.
Still confusion? Actual number is 50. Okay, and you guessed 25, and I tell you your number is lower. So next time, will you guess a number lower than 25?
No.
Higher than 25, I guess.
Yeah, it should be higher. It should never be lower than 25 because I already told you 25 is low. Lower than 25 will be even lower. So what we should do is, in that case, okay, this is the case, right? When your number is lower, next time the starting value should be guess plus 1 from till 26 you can think, not below 26. Right?
Hmm.
So what I'm doing, I'm changing the starting value now to 25, 26. 25 is lower, so it can think of 26, but it should not think of 25 or 24 or 23 or 1 or 2, anything. So I'm changing the starting value, I'm changing the range, okay, to this minimum range. This is what we're doing in our mind when we're playing this game. Okay, same thing. Let's say your number is 50 and you have thought of 75, right? Next time you will not think of a number, okay? You will not think of a number which is more than 75, 75 or more. That's why I said guess minus 1. Up to 76 only you should guess. So it should be between 26 and 76, not more than 76, not less than 26. With this simple fix, now you see how much time it takes, how many steps it takes, and number of steps is same as number of time, 9 steps. Okay, isn't it almost same efficiency as what we were thinking? 9 steps, 5 steps, okay, 4 steps. Number is 90 and it is able to guess. Okay, 41, it said higher. So 84 and now 96, it's lower, so you come down to 90, right? Within 4 steps, it could guess the number. Yes?
Yes, sir.
Okay. Now we'll do third steps. We'll do third problem. So here, computer is thinking a random number, but we are trying to control the range, and we are getting a more efficient result here. Okay. So again, I will go and save this here. I'll upload it to our location later. Now, one last step, one last change to this program. What we'll do here, we will say computer versus human. But this time, we'll use automation. Automation is, I'm trying to show you, what is manual, what is automation, and what is computer. So you are allowing computer to think. Computer is independently thinking. Okay, so you're actually playing against a computer. Now I'm saying human automation. Automation means it is we want to think, but we want to automate it. What automation? We will think of a number which is generally, so here what we're doing, okay, we are guessing a number between 1 and 100. But generally when we play, most of the time what we'll think, we'll start with 50. Okay, so let me show you in a paint what I'm trying to do. Okay, so you have number between 1 and 100. We have to guess the number. Let's say the number is 34. We have to guess this. So what we'll do, okay, first we'll say half of 1 and 100, 50. We are guessing 50, but it will say no, 50 is higher. So now your end has become here, correct? Now I will guess a number between 1 and 50, half of 1 and 50, 25. So 25 will be here. Okay, 35 should have been here somewhere. Okay, no problem. 25 will be here. So now I'm guessing half of 1 and 50. This is how manually we will think. Okay, so so not 25, but 25 is lower. So we bring this one here, right? Next time we'll think between 25 and 50. Did you get it what I'm doing?
Yes.
So half of 25 and 50, which is 37. Okay, lower. You bring this here and then, okay, higher, sorry. Higher means this should come here. So every time we are doing half, and most of the time this is how we think. Okay. So what my logic, I'm actually, it's not computer logic, it is my logic. Okay. This is assume that this is how I am thinking. So I am automating my thinking. Previous example, computer was thinking. We never interfered in their thinking, except that we played with the range. Now, this is how I will approach this problem. So I am trying to automate my thinking process using my logic. Okay. So coming back to the code, instead of thinking of number here, random guess, I'm going to say ST plus EN, okay, divided by 2. Okay, we need integer value. That's why I said double integer. We don't want to do with the decimal values. Now let's run this and see. 5 steps. 5 steps. 6 steps. 1 step. Okay. So this is another way of doing same program. Here, it's not computer. It is we. Okay. We want to automate our thinking. Now, if you have a different way of thinking, you can try to automate your thinking. Now you automate and you go to sleep, you can keep on playing. Right? Okay. So this is one way. Now let's say I want to see between this step, between what we just did, automation step versus computer step, which is faster. How do we do that? I want to know between automation step and the computer step, which one is faster? Okay, faster means less steps. Just by running one or twice, you will not be able to know, right? So what we do, we will run it maybe 50,000 times. Okay, maybe 1 lakh times. And then we'll take the average. And then we'll see if you run it 1 lakh times, this is what happens when you do probability. Okay, when you say that probability of getting head is 0.5, what does that mean? It means if you toss the coin 1 lakh times, almost 50% of the time you will get head. Just by tossing coin 1 time or 5 times, you cannot come to the probability. You have to simulate the situation. Simulate means you are running the same thing, very large number of times, and then you see the result. So probability can only be proven by doing simulation. You cannot prove, if I tell you, okay, the probability is 0.5, practically show me how it is 0.5. Practically you cannot show me. You can say that, okay, see, these are 2 options, so you'll get either this or this, so it is 0.5. But practically you have to do the simulation. Okay, let's try to simulate this. Okay, so how do we simulate? Every time you run this, okay, we are getting, okay, so let me save this also first. Simulation is running multiple times, correct? Now, while you're doing simulation, you don't have to print all these. Okay, so I'm going to comment this. This is going to take unnecessary time, right? Okay, So, okay. Let it be there for now. Okay. Uh, we'll generally hide all the print statement. We don't want, print statement to be run 1 lakh times. Okay. Now we have to do something which we have not done, and we will do in, maybe by Monday. Okay. Because here, see, when you run this, you are, okay, 1 lakh times, you need to store the values, 1 lakh values. Okay, first time how many steps, second time how many steps, third time how many steps, 1 lakh time how many steps, and that you have to do the sum, and then we have to divide. Correct? So, okay, so let's do one thing. Let me not use, I was thinking to use list. I will not use list. I will use a value here. Okay, list, we'll do the list when we come to the list. So I'm creating a value here called total, let's say total equal to 0. Okay, now this entire thing, num, right? Guessing also should be done 1 lakh times. So I'm going to put here for I in range. For I in range, 0 comma, okay, so I mean 0, so you don't have to say 1 lakh, 1,000, 10,000, 1 lakh. Is it 1 lakh? Yes. And we will move entire this thing into the for loop. Okay, to begin with, let's do with 10,000. Okay, then we will increase to 1 lakh. Okay, so I have moved everything. That means this entire program will run 1 lakh times. And your total, okay, what we have here should save the counter. Okay, so I'm going to say total equal to, or total plus equal to counter, right? And you don't have to print even this one also, or let it print so that we know that, okay, our program is running. Okay, so we'll say total. And once you are done with the program, then you will say print, okay, total steps equal to total, but we are not interested in total, right? We are interested in average. So we'll say average number of steps equal to total by 10,000, right? Or what I'll do is I'll create another variable called max. Okay, I'll give this so that, if you have to change it, you just change it once and it'll reflect everywhere. Okay, let's run it. See, 58,000, right? Those total steps, on average 5.8 steps. Okay, now when you do 1 lakh times, okay, you see this. It's like 10 times more, right?
Yes.
Computer has become slow because it's using memory capability, right? So your memories has to store all these, and memory will get cleared only when program stops. You see that? So on average, this automation has taken how many steps? 5.8 steps. Okay, so we can safely say that your automation step will take about 5.8 steps. Okay, and when you also run it, it will show you in similar range, somewhere between 5.5 to 6. It will not show you 6.5 or 5, 4.5. Somewhere in this range only you will get the answer, because we have run it 1 lakh times. Okay, So this is called automation. Sorry, not automation. Simulation. Okay, we have simulated this problem in the lab. Okay, when somebody says we have simulated the problem in the lab, this is what they mean. Now you want to measure how much time this program has taken to run this. Okay, time. So we have another module called time, and this is what we'll see later when we talk about module. Okay, and this is this time will give us functions to read the time only. So you have date, you have time, and you have date time. If you're dealing only with date, use date. If you're dealing only with time, use time. If you're dealing with both date and time, use date time. So we have three modules. Okay, here I want to read the time only. So here I'll say start time. So this will time will read my current machine time. Okay, and once I am done, here again I will say read my machine time. So it's reading my machine time before the start of the program and after the end of the program, right? And here I will say total time taken to run, okay, max steps is, okay, end time minus start time, right? So what was the time at the end when you finished? See, if I have to measure how much time did you take to do a task, so I'll see what time you ended doing the task. Okay, 3 p.m. When did you start doing the task? 2 p.m. So 3 p.m. minus 2 p.m., 1 hour. Isn't it? Same thing I'm doing. I'm measuring the time before start of the program and I'm measuring time after end of the program. And now I'm doing end minus start. So this will tell me, okay, how much time this took to run this program. Okay, let it take its own time. Meanwhile, let's take this one and we'll try to do something similar here. Okay, so this is computer versus computer here, right? So we'll take this program. Okay, and so what all things, okay, instead of changing entire thing, let's change just this part, right? Yeah, correct. That will be easy. So let me delete it. Let me not do anything here. Okay, so you see this 36 seconds. This will give you time in seconds. 36 seconds, and this is your, right. So this is the time taken to run 1 lakh steps. Okay, so what I'll do, so this is also giving us 5.8 only, right? So I go here, I'll replace this with new value. Okay, so I'll save this to upload. Now we'll use our computer to versus computer. Okay, so okay, random int, right? And here what we are doing, we will comment this part and uncomment this part.
Yes.
Right? That's it, correct? And everything else is same. Okay, now you run it. Okay, so we'll end it here today. Okay, we'll see this and we'll end it here. And tomorrow we'll start with strings. Okay, tomorrow we'll spend time on strings. So let's see this. See, so this has taken on average 7.5 5 steps. So what does this tell you?
It's taking more steps. than I-
Taking more time. So it tells you that, okay, having a plan, having a step is a better way to success than randomly doing something. Okay. If you do randomly something, you're taking 7.5 steps, 7.5 average steps. But when we came up with a plan, okay, we'll go with this plan, you will do better than doing random. Okay. So always have
Yes.
a plan. Don't do random stuff.
Yes.
Right? So yes, this is what I wanted to show you. Any questions before we end today's session?
So we use that for I loop just to to compare, right?
Where while loop? Which line am I talking
No,
about?
no, for I in range of max.
Just to run it multiple times, correct?
Yeah.
So we'll guess it. See, we cannot say by just one step.
Yes, yes.
Okay. In one step, you can, we have seen, right? We guess it in one step also.
Yes.
It doesn't mean that, you will be able to guess in one step. But if you
Yeah.
do it 1 lakh times,
Yeah.
then, you are averaging out.
Okay. Okay.
That's
Yeah.
what it's trying to tell you here.
It's guessing random, right?
Sorry, might be?
It's guessing random, and the human one is we have given some condition by 2. So
Correct.
yeah.
Okay. So see, first thing, we may not trust this number because see, I have a lot of things open, right? We have Zoom open, another browser open. So they will also take some time, right? So those things will also impact. So when you are measuring time, you have to make sure that everything is closed and you're running only one application. Okay. Because sometimes, those things will also interfere because we have one processor, right? So they'll also take some time. So, okay. So this time also you have to run it again and again. Okay. And you see that sometimes it might take 40, sometimes it take 30. Okay. You have to make sure that no other application is running on your machine. Okay. Then only we will trust this time. Okay. So just by running one time, we cannot trust this time. Maybe, while doing other thing, Zoom started doing some kind of thing in the background, and that would have consumed the CPU time, and our process would have become slow. Our programming would have gone slow, right? That's one.
Hmm.
Second thing is, obviously, yes, because we are adding an extra calculation step. Calculation will take extra time than randomly thinking. Here we are doing calculation, right?
Yes.
So if I tell you to do calculation and then or give me the random value, your random value will be faster than doing some calculation, right?
Yes.
So yes, that can take little extra time. Yes. So that could also be the reason why, though it took more number of steps, but time it took less. Which one? The computer versus computer.
Yes.